The next periodic table trend we're going to look at is called electronegativity. So by the end of this, we will be able to identify the electronegativity trends on the periodic table, rank atoms based on their electronegativity, predict the electronegativity of an atom based on its location on the periodic table, and explain how valence electrons impact electronegativity. All right. So electronegativity is the ability of an atom to take an electron. And remember the octet rule. An atom wants to have 8 electrons in its outer shell. So the closer it is to 8, the more electronegative it is, meaning the more willing it is to take another atom's electrons. So the trend for the groups, so that's for the columns, is that it increases from bottom to top. So this is increasing electronegativity. And that is because the atomic radius decreases, meaning there's fewer energy levels. So there's fewer electrons to shield the proton's charge. So if I have a proton in here and I have a bunch of electrons out here in a lot of shells, there's going to be less attraction for a new electron to come in, right? Because it's called shielding. These ones are shielding that positive charge in the middle, so the electron isn't as attracted to the middle. Whereas if I have a proton in the middle that only has a couple of electrons around it, then it's going to have a really strong attraction. Strong attraction, because that proton in the middle is able to really attract that negative charge. Let's put weak over here. Okay. The trend across the period, so across the rows, is that it increases from left to right. And that's because we have more protons on this side than we do on this side. Right? So with more protons, if I have a bunch of protons in here, it's going to really strongly attract electrons. Okay. The exception to this is noble gases, right? So if our valence electron shell is full, then there's no more room for electrons. So then there's no attraction because there's just no more room. And that is how valence electrons. So if the valence shell is full, okay, then we just can't add more electrons. And it won't want to give up any electrons because it's already very stable. Okay, so again, on your periodic table, you're going to draw in these arrows. So you're going to say, if I draw a yellow arrow and I label it increasing electronegativity, that way when you're asked which element has more electronegativity or less electronegativity, you have that trend on your periodic table. So here's our examples. We're going to look at iron and cobalt. So here's iron and here's cobalt. And looking at our trend, we know that our electronegativity increases going this way. So we're going to say, well, that means that cobalt has higher electronegativity, okay? And remember, across the period, that's because it has more protons in the nucleus for more attraction. Okay, and then if we look at gold and silver, so there's silver, there's gold, then we know that the trend for this one is going up. that means that silver is going to have a higher electronegativity. And again, that goes back to the shielding. So their silver has less energy levels. I'm not sure how to make that go away. Energy levels, sorry, levels. Oh, I changed colors. For less shielding. Okay, and I have the key over here for your reference.